Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to do the second numerical which is based on Gay-Lussac law. Initially we have did a numerical on that too, but this is of a different kind, so let us do it. So let us see the question and let us see what are they asking about. So they have said that 2.5 liter of gas at 20 degrees Celsius has a pressure of 1.8 atmosphere. So by increasing the temperature at constant volume, the pressure is increased by 80%. So find the final temperature in degrees Celsius. So in this case what we have to clearly understand is that they have mentioned that the volume is said to be constant. So since the volume is now been constant, so therefore there are two things that are being mentioned, because the temperature and the pressure. So temperature and pressure, in this case the both are being mentioned when the volume is been kept constant. And in this case, since the volume has been kept constant, so this 2.5 liter, the value that they have provided to us will have not so much influence in solving the problem, because it will have no use in solving the numerical, but yes, it has a concern about the particular experiment. So in this thing what we have to do is we have to calculate the final temperature if the pressure is being increased by 80%. So the first thing that we are going to do is we have to extract the data. So the first thing is we will do is to extract, or is to analyze that what is the given data provided in the question. So the thing is that they have provided us, so I would write it in the given data in this format, that the P1, that is the pressure that they have provided to us, is 1.8 atmosphere. While that of in that case the temperature is being mentioned, that is T1 is 20 degrees Celsius. So this 20 degrees Celsius should be converted in Kelvin. So what I am going to do is I'll add this 20 with 273 so as to get a value of 293 Kelvin. So this is the temperature T1. So now what they have said is they have said that the pressure is increased by 80%, and we have to calculate what would be the temperature of that. So but the pressure is said to be increased by 80%. So initially the pressure, which is 1.8, now it is now been increased by 80%. So I could write in this manner, that 1.80 multiplied by 180 divided by 100. So this is the method to predict the value if the a particular value has been given to us, and we have to analyze the percentage. Suppose if it has been increased, so we could find the another value of that particular thing that they have given to us. So I could analyze this thing, and let us see what is the answer we have got. 3.24 atmosphere. So basically 1.8 atmosphere is the first pressure that they have given us, and they have said that 80% of the pressure has been increased now, which makes us to get a value that the P2 value has 3.24 atmosphere. And on that case we have to calculate what will be the temperature, that is T2. So let us do it by using Gay-Lussac law, because they have mentioned the volume to be constant. So according to Gay-Lussac law, we have a relation when the two pressures and the two temperatures that have been given to us, and we have with respect to that when the volume is kept constant. So we have a formula as P1 upon T1, which is equals to P2 divided by T2. So in this case the P1 that they have given to us is, or we have did, is 1.8, while that of the temperature T1, which we have written in degree, which we have converted from degree Celsius to Kelvin, which was found to be 293, is equals to P2, that is 3.24, which is nothing but the 80% of that of the 1.8, which has been increased from 80% that of the 1.8 atmosphere. And now we have to calculate what would be the T2. So now the T2 value will be in Kelvin, because the 293 is itself represented in Kelvin. So therefore the T2 will be, I'll multiply this thing by 3.24 multiplied by 293, the whole divided by 1.8. So let us see what is the answer we could get. So we have got it as 527.4 Kelvin. So this is what we have got the value of temperature, that is T2. So but the thing is, we have to convert in degree Celsius. So first of all, what I'm going to do is, this is the value that I have got for the temperature, that is 5 to 7.4. So let us convert into degree Celsius. So it is easy to calculate, that is T2 in degree Celsius, because the value that they have given to us is basically 527.4, which is what we have calculated, that is 527.4 Kelvin. If I subtract it by 273 Kelvin, then I could get the answer in degree Celsius. How? See. So basically what I have got it as, so if I subtract 527.4 with 273, then the answer that I could get is 254, and this would be in degree Celsius. So this is the value of temperature in degree Celsius. Initially what they have, and let us see whether this is following the Gay-Lussac law or not. So this is the temperature in degree Celsius, but the first thing is what they have provided us when the pressure was 1.8 atmosphere, and while that of the temperature, which was, I'll write in degree Celsius itself. So suppose if I'm writing in degree Celsius, that is somewhere around 20 degrees Celsius, which they have provided to us, and the pressure P2 that has been increased by 80%, which means it is nothing but 3.24 atmosphere. And after that, what I have calculated is that when the pressure is being increased from 1.8 to 3.24, then the temperature, that is T2, is been now increased from 254 degree Celsius. So this is makes an indication that when the pressure is been increased, then the temperature also increases of a particular gas. So this indicates that we are talking about Gay-Lussac law, and the volume has been fixed. So this is how you could solve, and you would understand the numerical in a very better way, as well as you could understand the concept of each and everything in a very good way by solving the numericals also. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.